is meant by the term compound? Compound means a chemical combination of two or more elements. When two or more elements are chemically combined or joined together, we call that as compound. Mixture can be separated by physical process. A sequence of physical processes can be used to separate a common salt, sodium chloride, from a mixture containing sand and salt only. Give the order and the correct scientific term for physical process used to separate. So first what we will do, we will dissolve. Dissolving is there. The second, we will filter. And then the third, we will use crystallization. The boiling point of four different alcohols A, B, C, and D are given. The student suggested that the apparatus shown could be used to separate the mixture of alcohol. A hot water electrical heater is a fractionating column. Apparatus X need to have a cold water flow through it. Draw an arrow diagram to show where the cold water enter the apparatus as apparatus X. So the cold water should always enter from the bottom, and when it will absorb energy, it will leave from the top. Then name the apparatus. So it is a Liebig condenser. The part of a fractionating column is missing. This means the experiment will not work. Draw on diagram the part of a fractionating column which is missing and explain why the experiment will not work with this part of fractionating column missing. So you have a lid at this point, even at this one as well, but this is not necessary. The first one is necessary, and with the thermometer should be placed here. So why this will not work? Because the vapors will escape, as you can see from the marking scheme. The stopper is missing in the diagram, or gases or the vapors will escape. Suggest why a Bunsen burner is not used. Bunsen burner, when something is flammable, can catch fire easily. So we do not use Bunsen burner because this is a mixture of alcohol. Alcohol can easily catch fire. So we are using a water bath instead of using a Bunsen burner. A hot water bath cannot be used to separate alcohol. So a hot water bath cannot be used to separate alcohol C and D. Explain why. So what is the reason why alcohol C and D cannot be? Because this is based on the boiling point. If two substances have a same boiling point, then the second thing, as I mentioned in the question, the student apparatus could be used to separate a mixture of alcohols, and A is 56, B is 78, C is 122, and D is 160. So when we are using a hot water bath, so why it cannot be used? Because the temperature of the water cannot rise above 100, because when it reaches 100 it will start to boil. So temperature of alcohol cannot rise above 100 or more than 100. So alcohol C and D cannot be vaporized, because in this simple distillation, first is a vaporization, and then is the condensation or evaporation, and then condensation. So a hot water bath cannot work. Why it will not work? Because the boiling point of C and D is more than 100, so it cannot be vaporized by water bath. In the question, fluorium Fl atomic number 114 was the first made in research lab in 1998, and it was made by bombarding atom of plutonium with atomic number 94 with atom of Z. The nucleus of one atom of plutonium combined with the nucleus of one atom of Z, and this form a nucleus of one atom of fluorium. Suggests the identity of Z. So how we can identify Z? What is the atomic number which we want to prepare the element? We want to prepare element with atomic number 114. So finally, we need final result. We need 114. Plutonium is 94. So we have to bombard this with another element because the nucleus combined. We have to, how many, because atomic number is 94, the total we want 114. So we have to add 10 more protons. So which element is having 10 more protons when you go through the periodic table, like 10 protons in the nucleus? So atomic number 10 basically, and you can find neon is having atomic number 10. Calcium is 20, atomic number is 20. Neon is atomic number 10. This is atomic number, and this one is atomic mass. Calcium, when you check the calcium, you will find which belongs to group. This is a calcium which belongs to group 2, having 20. Yes, sorry, 114. I thought it was 104. In that case, it is calcium. That's right. Because 94 is there. We want 114, not, I thought it was 104. So we need 20 more electrons, 20 more protons, and 20 protons, it is calcium. That is why it Ca will be there. In which period of a periodic table we find this element? So which period of a periodic table we can find 114? 114. So this is 114, and when you check the period, the horizontal rows are refers to period, but because this atomic the periodic table is tilted, so this one is period 1, 2, 3, 4, 5, 6, and 7. So it belongs to period 7. Predict the number of outer shell predict the number of outer shell electrons in an atom. So how you will predict the number of outer shell electrons? You have to check the position in the periodic table. Which group it appear to be? So it appeared to be group 4. That's why it will have 4 electrons in the outermost shell. The reason why I use the term which group it appeared to be because for the element, the transition element, we don't specify them in a group, but according to the question, you just have to mention. So you will mention that the number of outer shell electrons, that will be 4. Two isotopes with 286 and 289, the nuclei of both isotope are unstable and emit energy when split up. Uh, State the term used to describe isotopes with unstable nuclei. So we use the term radioactive. Radioactive isotopes are there which are unstable and they tend to emit out radiations, or they tend to decay. Then complete the table to show the proton, neutron, and electron in an atom of isotope shown. So complete this table. Use a screen annotation to complete this. One hundred and 14 protons. This will also, because the element is same. How many neutrons for this one? 172, that's right. When complete, because both are atoms. Yeah, that's right. Because the neutral atoms, that is why they have the equal number of proton and electron. Only a relatively small number of atoms of fluorium have been made in the lab and the properties not yet been investigated. It has been suggested that it is a typical metal. So what are the properties of the typical metals? Physical properties. So properties of the typical metals, they have high density, they can conduct electricity, high melting or boiling will be same, shiny surface. The properties which you can write, I will show the marking scheme as well. So what you can write, these are the physical properties. They have high melting or boiling point, that's one thing. You can mention hard, dense, conduct electricity, conduct heat, malleable or ductile, sonorous, shiny or lustrous. You can mention these points. Not about the structure, you cannot mention that ionic structure, that's not like a refers to physical property. And these are metal. Typical metals have a lattice of a positive ion and the delocalized electron. So just one chemical property of the oxide. So what is a chemical? Because it's a metal and metal oxide, as they are typical metals, so metal oxides are basic oxides. Or you can mention they can form, or having a basic oxide can react with acid only. The next question, this question is about iron. Three of the raw materials added to a blast furnace used to extract iron from hematite are coke, hematite, and limestone. Name one other raw material added to the blast furnace. What else is added to a blast furnace other than this? We are adding a coke, we are adding hematite, we are adding limestone. But what else is there other than this? Air or oxygen? Hot air you can mention, or oxygen. Or hot oxygen also, hot air, oxygen. Then so 5 marks. A series of reaction occur in the blast furnace during the extraction of iron from hematite. Describe these reaction include one chemical equation for reduction of hematite and one chemical equation for formation of slag. So basically first what happened, carbon react with, better you write the in words as well, explain in word the each change. So carbon react with or coke react with oxygen to form carbon dioxide. Then carbon dioxide react with coke to produce carbon monoxide. Carbon monoxide is a good reducing agent which remove oxygen from hematite, and the equation for this, because one chemical equation for reduction, so the ore of the iron, which is hematite iron oxide, is there, reacted with carbon monoxide, result in a formation of iron plus carbon dioxide. And equation must be balanced. Then calcium carbonate decomposed to produce calcium oxide. Calcium oxide is a basic oxide which react with uh, silicon to form slag. So slag is CaSiO3. And for this one, you will mention calcium oxide is a basic oxide. React with acidic oxide, silicon of silicon to form slag. So this is the overall reaction which you will write the two equations and explanation for the formation of or extraction of iron from its ore. Iron extracted from hematite using a blast furnace is impure. Identify the main impurity in this iron. Basically, what happened when we try to purify iron, another impurity, and how it is removed in steel making. So, what is the main impurity now? So, main impurity is carbon now. And how carbon is removed? How it is removed? So, what we will do, we will add oxygen or blowing oxygen. Not air. Here we don't mention air. We supply oxygen. That's why we call a basic oxygen furnace. In the blast furnace, oxygen or air both can be used, but here normally we do not use. You can see here that's oxygen specifically. So impurity is a carbon below oxygen which react with carbon to form carbon dioxide. But don't mention air. In this part, when converting iron to steel, you're not supposed to write air. This question is about the masses, volume, and moles. So basically, it is related to the stoichiometry, which term is defined by the following statement: the average mass of naturally occurring atom of an element on a scale where the 12th atom has a mass exactly 12 unit. So what we call this a statement, we call that as relative. Basically, what is the definition of relative atomic mass? Relative atomic mass is a mass of atom which is compared with the 12th part of carbon 12. So we call that relative atomic mass. If it was a mass of molecule which is compared with the 12th part of a carbon, then it will be relative molecular mass. So if the definition, sometime in exam you find this as define relative atomic mass, so this is the definition of relative atomic mass. So you have to memorize this definition, learn. Butane C4H10 has a relative molecular mass of 58. Potassium fluoride is having a relative formula mass of 58. Explain why the term relative molecular mass can be used for butane but cannot be used for potassium fluoride. Basically, look for butane, what happened when one molecule of butane is there, it is C4H10. What is the meaning? It means that it contains 4 carbon atoms and it contains, there's a double bond. Sorry, butane is there, so there's a single bond and there are 10 hydrogen. So one molecule contains 4 carbon atoms and 10 hydrogen atoms. That is the total number of particles present in one molecule. But in case of potassium fluoride, it does not happen like this because it's an ionic compound, and ionic compound, what it contains? It contains ion, the lattice. So there are positive ions and negatives. So we are not finding the mass of whole structure. We are just finding the mass of the simplest ratio between the atoms present in the structure. That's why we call that as relative formula mass. Is it clear, this statement? You can see here. So simply, the molecular mass is used for covalent substances and formula mass is used for ionic substances. Because for ionic substance, when we say potassium fluoride, it does not mean we have one potassium and one fluorine. But when we say that we have a butane, so it means we in a molecule we have 4 carbon and we have 10 hydrogen. Is it clear? This is statement why we use a molecular mass. So molecular mass is actually a term which is used for covalent substances because they have that's actual number of the atoms present in the structure. But for ionic compounds, we don't say molecular mass, we say formula mass. Formula mass is basically, it's showing the simplest ratio between the atoms present in the structure. So for covalent substances, when you have a covalent substance, when we say we have one molecule of butane, so one molecule of butane means it contains 4 carbon atoms and 10 hydrogen. That is the number of the molecule, number of the atoms present in one molecule. So the total, when I find carbon is 12 multiplied by how many 4 are there, and hydrogen is 10, number of hydrogen 10 multiplied by 1. That will be 48 plus 10, that's equal to 58. So 58 is a mass of one molecule. But when we say potassium fluoride, so potassium fluoride is ionic structure. Ionic structure have a lattice, like there's one potassium ion, then iodide ion, fluoride ion, potassium, then fluoride. And this will continue, repetition is there. So we are not finding the mass of whole structure, we are only finding the mass of a simplest ratio of the ions present in the structure. Like the simplest ratio between potassium and fluorine is 1:1. So we are finding the mass of a simplest ratio of atoms present in the structure. So for ionic compound, we don't say molecular mass, what we call, we use the term formula mass. Is it clear now? So potassium is 39 plus fluorine is 19. So 39 plus 19, that is equals to 58. Is it clear, this part? In the question, 0.095 grams of sample of gaseous element Y occupies 60 cm cube at room temperature and pressure. Determine the number of mole of element Y in 60 cm cube. So we have 0.095 sample of gaseous element and it occupied 60 cm cube. So whenever gas is there and you need moles, so the formula moles is equals to volume of a gas divided by 24. So what is the volume of the gas? But the volume of the gas should be in dm cube. Here it is in cm cube. So we cannot substitute, otherwise if you substitute you will get a wrong answer. Volume should always be in dm cube. So to convert cm cube into dm cube, first what we will do, so centimeter cube to decimeter cube will divide by 1000. So 0.06 decimeter cube, and then 0.06 decimeter cube divided by 24. What's the answer? 0.06 divided by 24. 2.5 exponent minus 3. So 2.5 exponent minus 3. So I can write 0.0025. You can write in scientific notation as well, or you can write in simple decimals. Then calculate a relative molecular mass of element Y, hence suggest the identity of element Y. So we have the formula moles is equals to mass in gram divided by molecular mass or atomic mass. If element exists as a molecule, then it will be molecular mass. If element exists as an atom, then it will be atomic mass. But our subject here is molecular mass. So molecular mass will be mass in gram divided by moles. So what's the answer? Mass in divide 0.095 divided by 2 exponent. So that's equal to 38. So molecular mass is 38. So first thing, because the element is a molecule, so it means it should be a non-metal, because not for non-metals we use the term molecular mass. For metals we use the term atomic mass because they are not like joined together. So it's 38. So which non-metal is having a molecular mass of 38? Which non-molecular, not atomic. This is a molecular mass. Like group of atoms, the element existing as a group of atom, which is having the total mass 38. So, and it should be a non-metal because for non-metal, strontium, when you check the periodic table, you find 38. You find 38. This is 38 is atomic number. 88 is strontium is atomic mass, but that cannot be strontium. It is fluorine. Why it is fluorine? You can see because it's a molecular mass, so we are sure that this is in this region where molecules exist. Then which molecule is this? You have a fluorine molecule. How we conclude fluorine molecule? Because fluorine exists as F2. So it will be 19 multiplied by 2. 19 multiplied by 2, that will make 38. So we conclude that this element is a fluorine. So fluorine, and from the information you can identify, how you can identify from the information given, because they mentioned this element is existing as a gas. So if element is existing as a gas, so it's a non-metal. So you have to check group 8. But for group 8, why it cannot be group 8 element? Because for group 8, they exist as, they have atomic mass, not molecular mass. So relative molecular mass will be 38 and identity of element, that is fluorine. You will write in words fluorine. Then 1.68 gram of phosphorus was burned and formed 3.87 grams of oxide of phosphorus. What is the empirical formula? To get the empirical formula, we should know the mass of element or the percentage of element present in a compound. So 1.68 gram of phosphorus is burned in air to form 3.86 gram of phosphorus oxide. So how much oxygen is present in this phosphorus oxide? So how we will know amount of oxygen? Because the total mass of phosphorus oxide is,
Ratio.
to get the empirical formula, we'll take the ratio. But first, to get the amount of oxygen, we'll subtract 3.87 minus 1.68. What's the answer? This will give us amount of oxygen in phosphorus, the mass of oxygen in phosphorus, 1.17. Now to take the empirical formula, 2.1, 2.19. Okay. Yeah, because it's 3.87, 1.6, so 2.19. Now to get the empirical formula, first divide by atomic mass. So what is the atomic mass of phosphorus? You can use the periodic table. It will be 31. So you'll divide this by 31. 1.68 divided by 31. What's the answer? 1.68 divided by 31. 0.0541. So this one is 0.0541. And 2.19 divided by atomic number 16. 0.1368. Better when you're solving a question related to empirical formula, take more significant figure. so that at the last only try to round up. Don't try to round off in between. Like 4 decimal places you will take. Then take the simplest ratio, that's divide by smallest value 0.0541 and 0.0541. This will be 1. What is the answer for oxygen? 0.1368 divided by 0.541. 2.53 or 2.5. So whenever one of the values 2.5, 3.5, 4.5, what we will do, we'll multiply both of them by 2. So basically the answer is P2O5, the empirical formula. Is it clear? Another oxide of phosphorus has empirical formula P2O3. So this is another part which is having empirical formula of P2O3. One molecule of this oxide contain 4 atoms of phosphorus. Calculate the mass of 1 mole of this oxide. Look, the empirical formula is given. Empirical formula actually shows the simplest ratio. So the simplest ratio between oxygen and phosphorus is 2:3. But now they're saying one molecule contains 4 atoms of phosphorus. So if 4 atoms of phosphorus, how many atoms of oxygen will be there in the molecule? The ratio is 2:3. The ratio should not change. So it will be 6. Empirical formula shows simplest ratio. So if a molecule of this is an empirical formula. Empirical formula means the simplest ratio between phosphorus and oxygen is 2:3. So if there are 4 phosphorus atoms in the molecule, then because the ratio should be 2:3, so then oxygen should be 6. Because when you simplify this, you will all get 2:3. So the actual molecule contain 4 phosphorus and 6 oxygen. We need mass of 1 mole or 1 molecule. What is the mass of 1 mole? So how to find the mass? Because phosphorus is 31 multiplied by 4, that's equal to 124, plus oxygen is 16 multiplied by 6. The final answer is 220. Your relative molecular mass is also the mass of 1 mole. Calculate mass of 1 mole of this oxide of phosphorus. So relative molecular mass is also the mass of 1 mole. Like example, if I say what is the mass of 1 mole of sodium oxide? So mass of 1 mole means molecular mass of sodium oxide. I told you mole is another name of atomic mass or molecular mass expressed in gram. So when atomic mass or molecular mass we represent in gram, we also call that as mole. Is it clear, this part? So 2 marks.